Object-oriented design and programming. So in this, we are going to see about variables, constants, and static variables. What is a variable? So variable can be termed as a symbol or name that is given for a value. Whenever we have to use any values in our program, we have to store it in a memory location and we are going to name that memory location. So that is nothing but the variables. So the values assigned for a variable can change over time. It is not a constant value. So variables can be of any data type. It can be an integer, it can be a float, or it can be a character, or it can be a string, or it can be a double, anything. The size of the variable also depends on the data type it holds. So in this example, an algebraic expression is given a equal to b plus c. So where a, b, c are termed as variables. How can we declare a variable? So in C++, we can declare the variables whenever we need it. In case of C, we have to declare it in the beginning, but in case of C++, it can be declared anywhere in the program. So how is the declaration made? So first we have the data type and the variable name that is ended with a semicolon. So here are a few examples of how to declare a variable. Here age is the variable name and int is the data type and it is ending with a semicolon. So this is how a variable is declared in a C++ program. We can initialize the variables while it is declared. So that is called as initialization. Here int age is equal to 20 is an initialization where int is the data type, age is the variable name and 20 is the initial value that is assigned to the variable age. When initialization of variable is not done, then garbage values are only considered. For example, in the following program, we will see about how garbage entries are used. And I want to tell you one more thing, that when a particular variable is initialized, again that value can be changed because it is a variable. So here int age is equal to 20 is initialized to the variable age, but later in the program if I have to change the value of age, it can be done. So now coming to the garbage value replacement. Here is a program to illustrate how garbage value is used. So here we have declared a variable a1 and no initialization is done to this a1. So if we try to print the garbage value of a1, then obviously a garbage value is getting printed. But after initializing the variable a1 to 100, if I am trying to print a1, now the value 100 is getting printed. So when a variable is not initialized with any values, it tries to print only the garbage value. So that is the garbage value when when the variable is not initialized, automatically a garbage value is given. So what is a garbage value? It is referring to a memory location and that in that memory location any values can be stored. So those random values are termed as garbage value. How can I initialize more than one variable? So here is the method. Here in this program, int a, b, c, d are four variables of the data type integer, and a equal to b equal to c equal to d equal to 55 is a proper method for initializing multiple variables if all the variables tend to have the same value. So how is it done? You can check out in this figure. So here 5 is assigned to D and now the value of D changes as 5. So again when it is chained assignment is done to C, automatically C will hold the value of 5 and this carries over until it reaches A. So all A, B and C and D will have the values as 5 as of this figure is concerned. And now coming to the program, here A, B, C, D are all assigned with the same value 55. So when I am trying to print the values of A, B, C, D, all will hold the values as 55. So this is how more than one variable can be initialized. So it is also termed as chained assignment. What is dynamic initialization? So usually initialization can be done while the variable is declared. Similarly, at any point in program, the values can be dynamically assigned. That is also possible. So how this dynamic assignment or dynamic initialization is done? So here is an example where A, B, C are declared as integer, float and character. An integer value is received as an input from the user, a floating point number is received as an input from the user, and it is stored in the variable B. Similarly, a character is received from the user and it is stored in the variable C. So now while declaring, only declaration is done and no initial assignments are done. But while executing these set of codes, like when the values are received from the user, automatically the values that are given by the user are assigned to A, B and C. So this is a point to explain about dynamic initialization. So all type of variables can be initialized dynamically. There are two types of variables, local variable and global variable. Local variable is nothing but when we are declaring a variable inside a function or a subroutine or inside a method, then the scope of the variable lies only inside that particular function or subroutine or procedure. So that is termed as local variable. So what is a global variable? Global variable scope will be towards the entire program. So all parts of the program can easily access this global variable and can make changes to it. So these two are the types of variables, and this figure clearly explains what is the scope of a local variable and what is the scope of a global variable. What are the rules for naming the variables? So the name that is given to the variable are termed as identifiers. So these identifiers have certain rules, or we have some naming conventions followed for giving the identifiers. So the main rule is the identifiers should begin with a character or underscore, and it should not start with a digit. Similarly, no spaces or punctuations are allowed between the characters. Only underscore is allowed. Identifiers in C++ should not have any of its reserved keywords like main, do, if, else, enum and all those. Identifiers can also be a combination of lower and uppercase characters. So here I have given some examples. All these are valid identifiers, like SU and cabs in capital M is given. So this is actually a valid identifier in C++. So I have given some list or examples of valid identifiers and invalid identifiers. So it should not begin, as I said, it should not begin with the digit. So to sum is not valid since it is beginning with a digit. And the second one, sum of dig, is also not allowed because there is space in between these variables. And similarly, sum of dig apostrophe s is also not allowed since only underscore is the accepted punctuation mark and other punctuation marks or spaces are not allowed. So these are the rules that are to be followed for naming the variables. So name of the variable is nothing but the identifiers. Here is an example program that uses feet and inches and it converts it into centimeters. So there are three declarations that are made for the variables feet and inches, and similarly centimeter is declared as a double variable. Here feet and inches are initialized to 0, and using dynamic initialization the values for feet and inches are received from the user. So after receiving the feet and inches from the user, both feet and inches are converted to total inches and is stored in the variable total inches. So after converting the feet and inches to total inches, again, this inches is converted to centimeters by multiplying it with 2.54. So finally, we are using cout to display the feet and inches. What is the feet and what is the inches and what it is equivalent to and what centimeter value that is providing. So this is a simple example to define how feet, inches and centimeters are declared. Now coming to constants. Constant are nothing but it is just opposite of variable. The values in the variables do change over time in the program, but in case of constant, once you declare a particular thing as a constant, it cannot change during the execution of the program. So that is what a constant refers to. It is so inflexible. When we are using variables, it is very flexible because it changes, the values in the variables changes over time, but in case of constants it is not so. So it is too inflexible, and so it is less often used than variables in any of the programming. We have three main types of C++ constants: numerical constants, character constants, and symbolic constants. The first one is a numerical constant. So what is a numerical constant? You have two types again in that: integer constant and real constant. So when I consider integer constant, any whole number can be represented as an integer constant. There should not be any decimal points or no fractions are allowed for declaring or for initializing the integer constants. It requires minimum 2 bytes and maximum of 4 bytes of memory. Similarly, integer constants can either be positive or it can be negative, or even 0 is allowed and it is considered as an integer constant. Normally, when we give an integer value without a sign, it is considered to be a positive value. So here I have given, in the first line, I have given all the values that are valid constant, integer constant, and in this fourth line I have stated all the invalid integer constants like 2.3, dot 235. All these are invalid integer constant, as integer constants will not be having any decimal or fractional values. Similarly, integers can also be used for representing octal numbers and hexadecimal numbers. So what is an octal number? The numbers with base 8 are termed as octal number. Usually while representing it in the programming language, octal numbers will have a leading 0. So for example, 027 is an octal number, 036 is an octal number, 077 is an octal number. So octal numbers will have base 8 and it ranges from the values numbers 0 to 7. Similarly, integer constants can be used for representing the hexadecimal values as well. So hexadecimal numbers are the numbers with base 16 and it usually ranges from 0 to 9, and the values A, B, C, D, E, F represents 10, 11, 12, 13, 14 and 15 respectively. So these are represented with leading 0x. So whenever a particular number has a leading 0x, it states that that particular number is a hexadecimal number. Now coming to real constant. So real constant is nothing but a floating point constant. Usually when we are handling or when we are dealing with values related to length or related to height or weight and all those cannot be represented only using integer constant. So that's why real constants play a role, and usually real constants are represented either in exponential form or fractional form. So usually the real constants will have a decimal point, and it as such of integer constants, the real constants can also have positive or negative value, and when a number is represented without any sign, it is considered as a positive value. Exponential notation for the real constant is like this, like 2456.123 is a fractional part that can be represented into a exponential part as 2.4561 x e to the power plus 3. So what does it refer to? Let's see. So here the part preceding e is termed as the mantissa part, and the part that is after e is known as an exponent part. So here 2.4561 is a mantissa part and plus 3 is an exponent. So the e can be represented either in uppercase or lowercase, that doesn't matter, but mantissa should be a real number. Like it should either be a floating point number or it can be an integer number, and it can be a positive number and it can be a negative number. Similarly, exponent should be a should be an integer. It cannot be a floating value, it cannot be a decimal pointed number, and it can either be a positive number or a negative number. So these are the two variations for representing the real constants. The last type of constant is a character constant, where you have single character and string constant. So what is a single character constant? Whenever a specific value of, it can be either a letter, it can be a digit, or it can be a punctuation mark, or it can be anything that is represented inside a single quote, is represented as a single character constant. Even white spaces are considered, can be considered as a single character constant when it is included inside a single quote. Similarly, the string constant is nothing but the sequence of characters that are enclosed with double quote. Okay, so here string can be a combination of all types. For example, hello is included within double quotes, India is included within double quotes, 444 is a number that is included within double quotes. So all these are considered as a string constant. Last type of constant is symbolic constant. So symbolic constant are nothing but the way how we are going to define a specific value as a constant. So there are primarily two ways that are used for defining the constant. The first one is by using the hash define preprocessor directive. So when I have to declare a specific value to be a constant value, then I can use hash define, the name of the constant, and the value that is going to be assigned for the constant. So here hash define price 152 is given, where 152 is the constant value and the name of the constant is price, and it is defined using hash define. So every time the preprocessor finds the word price, it will replace it with the value 152. Similarly, we also have const keyword to declare a specific value to be a constant value. So here const int price is equal to 152 is given, where this price is a constant value and it cannot change over time, and it is of the type integer. So this is how const keyword can be used for symbolic constants. So here is an example that uses both hash define and const for defining the constant. So this is a simple program to find the volume of a sphere in C++. So we have to include iostream and math.h. I'll tell you why math.h is used here. And after that, using hash define, pi value is defined. So what is the pi value? It is accessed as 3.14159. So this is a constant value that is assigned to pi. Similarly, hash define can also be used for assigning new line. So new line is nothing but the name that is given to the constant, and /n automatically will provide a new line. So that can also be used. So I just wanted to describe about this new line. So that's why I have used this preprocessor directive here for defining the constant new line. And in the program we have float VAL. So value is equal to 1.34. Here VAL is the name of the constant that is assigned with the value 1.34, and it cannot be changed over time. Float R is defined. So R is the radius that is received from the user. So when the user is entering the value for the radius, it is automatically stored in R. So this is a dynamic initialization. And after doing that, the volume of sphere is found using the formula VAL. VAL is equal to 1.34. So 1.34 is nothing but, we know the volume of sphere formula, isn't it? Like 4 by 3 pi r cube is the formula. So instead of 4 by 3, VAL is substituted as 1.34. So VAL into pi. So pi value is again substituted with 3.14159 into POV of r cube. So r comma 3 is nothing but r cube, power of r to the power cube. Okay, so that is a formula, and POV is a function that is exclusively defined in math.h. So that is the reason we are including math.h. So finally, after calculating the volume of the sphere, it is displayed using Cout. That is, the volume of the sphere is equal to so on so here in this example the radius is given as 4. So once the radius is given, the value is calculated as volume of sphere is 269.423. The last topic is static variables. So what is a static variable? So the variables that are defined as static is termed to be permanent. That is, there cannot be any further modifications that can be done to the static variables. It can be initialized once, and whenever we are trying to access the static variables, it is pointing to the same memory location and no copies of the variables are created each and every time it is called. So that is why it is termed as static, and it is allocated for the lifetime of the program. So it is not a temporary variable. So always the compiler will persist the variable till the end of the program. It will use the variable till the end of the program. It will not delete it. Similarly, static variables can either be a local variable or it can be a global variable, or you can even specifically you can declare a static variable inside a function or whatever. So wherever it is defined, the static variables are permanent variables and it is by default initialized to 0. Whenever a variable, a normal variable or a non-static variable is defined or declared, and when it is not initialized, as we have seen earlier, it is assigned with some garbage value. But in case of static variable, whenever we are not initializing it, it is initialized automatically, or by default it is initialized to 0. So that is the major difference between static and non-static variable, and also the static variables are alive until the execution of the program. So how to define a static variable? Here static data type variable name equal to some values given. So here static int is the variable data type name and number is the variable name is equal to 12. So this is how we have to initialize or declare a static variable. What is the major difference between static and non-static variable? So as I have said earlier, static variables are permanent while the non-static variables are storing the data only for temporary use. C++ initializes the non-static variable each time it is created. We all know that it is initialized to 0 whenever an external initialization doesn't happen. But in the case of static variable, obviously it is initialized only once and it is assigned with 0 at startup time. No garbage value is initialized. So here is an example program to explain about the static and a non-static variable. So static variable is a permanent variable and non-static variable is a temporary variable. Here inside a for loop, each and every time the program comes inside, the compiler comes inside this for loop, the variable temporary is initialized to 1 and permanent is a static variable that is also initialized to 1. So what usually happens is each and every time it enters the loop, the value of temporary and permanent will get incremented. But since it is initialized inside the loop, automatically temporary and permanent will be assigned as 1. But since the permanent value variable is a static variable, the same copy is accessed. So you can see the output each and every time it is executed. Temporary is assigned as 1 only, but permanent value increases by 1 each and every time. Okay, so since temporary plus plus and permanent plus plus is used, that is increment operation is used here. Temporary, though it is incremented, again the value is deleted and it is reassigned with 1 once it enters the loop. But in case of permanent, it is a permanent memory. So each and every time it is getting inside the loop, it is not reassigned. It is not getting reassigned with 1. Instead, it is getting incremented. So that is about static variables. We can use the word static to a class, to a function and also to a variable. For now, I am just closing this with static variables, and later we'll be seeing about the static class initialization and all those, how to call a static class and how to define a static function. Thank you.